My name is Liberato Manna and I'm head of the nanochemistry group at the Italian Institute of Technology.
And I am Roman Krane. I'm a senior scientist in the nanofabrication unit, also here at the IIT in Genova.
I am Guglielmo Lanzani. I'm the head of the Center for Nanoscience and Technology of the Italian Institute of Technology at Politecnico di Milano and professor of physics for the Politecnico di Milano.
I am Margherita Zavelani-Rossi. I am assistant professor.
I am Margherita Zavelani-Rossi. I am assistant researcher. We are at the Department of Physics of the Politecnico di Milano.
And we work in the Ultrafast spectroscopy group.
The title of our work is lasing from self-assembled microcavities of colloidal cadmium selenide cadmium sulfide quantum rods. The starting material in our work is made of cadmium sulfide nanorods, which are shorter than 100 nanometers in length and which encase a tiny cadmium selenide domain in the inner part. Upon photoexcitation, electron hole pairs are created in this material, but because of the peculiar alignment of the valence and the conduction bands for cadmium selenide and cadmium sulfides, electrons are basically localized throughout the whole rod volume, while holes localize themselves mainly in the cadmium selenide domain. And this peculiar property should help to improve optical gain and to achieve lasing in these materials.
In our work, we use the coffee stain effect to align nanocrystals. So the coffee stain effect is when you spill coffee. And now we need to wait until the liquid is evaporated and the coffee stain deposits are visible. But this takes a bit too long, so we already prepared this and we have some coffee stains here. And you see that most of the material is deposited on the outer edge of the evaporated droplet. Now let's see what the coffee stain does if we deposit tiny droplets of nanorod solution on glass substrates. So what we do is we spray the nanorod solution with a pipette on a microscope glass slide, and it turns out that the solution forms these hundreds of micron size droplets with a very well-defined coffee stain ring, as you see here in this dark field microscope image. And the fluorescent image shows you that most of the nanorod solution is deposited in the outer coffee stain ring. It turns out that the borders of the coffee stain ring are so well defined that they can work as microresonators. And when in our experiment we illuminate the sample with a UV femtosecond laser from above and collect the light from the side, we see stimulated emission, and in the end at high pump fluences we see lasing modes from this self-assembled microcavity of nanorods.
Concluding, we demonstrate that nanorods undergo self-assembly and self-recognition. This is the biomimetic approach, which is followed also by nature to obtain complex structure which perform a specific function, and it has implication in technology because it's fully solution possible, and for instance it can be adapted to a simple, cheap and potential interest process like inkjet printing.
Stop! Ferma la macchina, vai!